with respect to y and put the limit, so you will get the area with y-axis. Now moving to the first question, we are given find the area bounded by the curves 3x square plus 5x equals to 32 and y equals to mod x minus 2. So looking at the first curve, if we will write it, it will be x square equals to minus 1 by 3 or minus 5 by 3 y minus 32 by 5. So this is an equation of parabola whose vertex is at x equals to 0 and y equals to 32 comma 5. Let's plot this parabola. So it's y equals to 32 comma 5 here, 32 by 5 here, and x is 0. And y equals to mod x minus 2. We can write it as x minus 2 for x greater than equals to 0 and minus x plus 2 for x less than 0. So for this line, if we can draw, then this, let's say this is the point x equals to 2. For x greater than equals to 2, we are having it's equal to x minus 2, so the slope is 1. This will be the line. Here the slope is minus 1, so this will be the line. We can see that the product of slopes is minus 1, so this angle is 90 degree. Now we have to we have to find the area bounded between these two curves, that is we have to find this area. To find this area, first of all we need this coordinate x1 and this coordinate x2, which we can easily find by solving the two equations. And then what we have to do is we have to find this area. So if we will integrate from x1 to x2 the equation of the curve, that is y dx, we are finding the area with respect to x-axis. So this value will come out to be x1 to x2, and y, from here we can write the value of y as 32 minus 3x square by 5. So that is 32 minus 3x square by 5 dx. Now, if you will do this, then you will get this whole area. But we do not require the whole area. We require the only area in which we are getting these two lines of intersection. So here we are having one triangle here. Let's name it A, B, C, D, E. So from this area, let's say it is A1. This is A2 and A3. So A2 will be equals to half of base into height. And this area will be also equals to half of base into height. This length is 2. This is length from origin. This is x1. The mod of x1, we will be getting x1 as negative value. So we can easily find these areas and subtract it. Okay. So moving to the solution, we have wrote this one, and this is the curve. This is the required area we need to find. So the point of intersection can be found out by, see, the equation was 3x square plus 5y equals to 32. So we are having from here y equals to, for x greater than 2, we are having y equals to x minus 2. So put this value, so 3x square plus 5 into x minus 2 equals to 32. So this will be 3x square plus 5x minus 10, and minus 32, it will be minus 42 equals to 0. So this will be 3x square plus, use the Sridharacharya formula or anything. So you will get x equals to minus 5 plus minus under the root b square minus of 4ac. So you can solve this quadratic equation and you will get the value of x equals to 3. So this coordinate is x equals to 3. Put x equals to 3 here, you will get y equals to 1. So we can see that for this triangle, this length is 1 and this is 1. So area will be equals to half of 1 into 1. So it will be half. Similarly, for this, we will putting y equals to minus x plus 2 in this equation and then solving the quadratic equation, you will get the value of x equals to minus 2. Putting this value of x equals to minus 2 in here, you will get y equals to 4. So we are having this area, and in this length is 2, this length is 2, and this is 4. So for this triangle, it will be half base into height. So that will be 8. So these two areas we have found out, and this value we can find easily by integration. So 1 by 5 will be out 32, integrating 32x minus 3x square, on integrating it will be 3x cube by 3, so x cube, and then putting the limits. So on solving, you will get the area equals to 33 by 2. Moving to the next question, the area of the region bounded by y equals to mod x minus 1 and y equals to 1. So for y equals to mod x minus 1, we can write it as x minus 1 for x greater than equals to 1 and minus x plus 1 for x less than 1. So if we will draw the lines, so this is a straight line and having the slope 1. This is a straight line having slope minus 1, passing through x equals to 1, y equals to 0. And we have to find the area enclosed for this, and if we will put x equals to 0, y will be 1, so these two will intersect here. Now we have to find this area. We can see that this is a triangle, and since this is having slope 1, this is having slope minus 1, so this angle is 90 degree. You don't need to do integration in here. You can directly see the curve, and this curve is coming out to be a triangle. So we can easily find the area of triangle by using the basic of half of base into height. Now you draw it. So this length is 1. This length is also 1. And this point we will know when y equals to 1. So if you will put y equals to 1, you will get x equals to 2 in here. So this is a triangle whose base is of length 2 and height is 1. So area will be half base into height. So it will be 1. So our option A is correct. Moving to the next question. We are given The slope of the tangent to the curve y equals to fx at the point x comma y is 2x plus 1 and the curve passes through 1 comma 2. The area of the region bounded by the curve, the x-axis and the line x equals to 1 is. So first of all we can see the slope of the tangent to the curve is this, that is dy by dx is equals to 2x plus 1. Now this implies that dy equals to 2x plus 1 dx. On integrating both sides, we will be getting integration of dy equals to integration of 2x plus 1 dx. So y will be equals to 2. For integration of x, it will be x square by 2 plus x plus c. Now it is also given that this curve passes through 1 comma 2. So satisfying this point, we are having 2 equals to 1 plus 1 plus c. So c will be equals to 0. So we can see that we are having the curve y equals to x square plus x. Now it is required to find the area of the region bounded by the curve, the x-axis and the line x equals to 1. So we have to just find the area from 0 to 1 of y dx. So that is 0 to 1 x square plus x dx. On integrating it will be x cube by 3 plus x square by 2, and while putting the limits, so it will be 1 by 3 plus 1 by 2 and the answer will be 5 by 6. So correct answer is option B. Moving to the next question. The area bounded by the curves y equals to mod x minus 1 and y equals to minus of mod x plus 1. So first of all, we should rewrite these two. So for y equals to mod x minus 1, we will write it as it is equals to x minus 1 for x greater than equals to 0 and minus x minus 1 for x less than 0. Similarly for this one, y equals to, so this will be minus of mod x plus 1. So it will be equals to minus x plus 1 for x greater than equals to 0 and x plus 1 for x less than 0. Because we know that mod x will be equals to x for x greater than equal to 0 and it will be equals to minus x for x less than 0. Plotting the curve here. So for the first one, for x equals to 0, we are having y equals to minus 1. And for x greater than equals to 0, this is x minus 1. So the straight line would be like this with the slope 1. And for x less than 0, it will be a straight line like this with the slope minus 1. Similarly, this one will be for x equals to 0, y is 1. So this coordinate is 0 comma 1. This was 0 comma minus 1. And we can see for x greater than equals to 0, the slope is negative. So it would be like this. And for x less than 0, the slope is positive. So the straight line will be like this. These two will meet at this point. As we can see, if you are equating these two, for x greater than 0, then y x minus 1 equals to minus x plus 1. So it will be for x greater than equals to 0, this line is minus x plus 1 and this is x minus 1. If you equate x minus 1 is equals to minus x plus 1, so you will be getting 2x equals to 2, so x will be equals to 1. So this length is 1. Similarly, lengthwise this will be 1. The coordinate will be minus 1 comma 0. This coordinate is 1 comma 0. And this is also 1. So we can see we are having the two triangles in here. The first triangle, upper triangle, will have area half base into height, that is 1, and the lower will also have the area 1, so the total area bounded is equals to 2. So here the correct option is B. See, in these type of questions you don't need to put integration. You can directly see the figure, you can directly see what type of structure it is forming. Moving to the next question, we are given to find the area of the region bounded by y equals to root x, x equals to 2y plus 3, and y-axis lying in the first quadrant. Y equals to root x means x equals to y square, or we can write it y square equals to x. So this is an equation of parabola. So this parabola is plotted for only positive values of y, and the line is x equals to 2y plus 3. We have to plot the curve for the first quadrant only. So this is y equals to 1 by 2x minus 3 by 2. So it is having slope 1 by 2, and intercept with y-axis is minus 3 by 2. So it would be coming from here somewhere. Now for this point, this straight line will go like this. We can find the area of point of intersection. Now y square equals to x, and x we are having 2y plus 3. So y square minus 2y minus 3 equals to 0. So that would be y minus 3 into y plus 1. So the point is y equals to 3. Putting y equals to 3, we will be getting and for y equals to 3 we can find this area, find the value of x in here. So x will be equals to y square, that is 9. So this point has coordinates 9 comma 3. Now we have to find the area bounded between these two curves. So what you can do is you can either go for the limit on the y-axis, or you can either go for the limit on the x-axis. For if y going for the y-axis, then from y equals to 0 to y equals to 3, we are integrating this value. If we will be finding this area and this area, so it will be line 2y plus 3 minus this curve, and its value is x equals to y square dy. See, we have to find this area. So we have found out the area included between the line and y-axis, and we have subtracted it from the area included between the curve and the y-axis. So we will get the area bounded between these two curves. So on solving, you will be getting 2y square by 2 plus 3y minus y cube by 3, and putting the limit 0 to 3. So that will be 9 plus 9 minus 27 by 3 and minus 0. So we would be getting answer 9. So our correct option is option C. Now moving to the next question. If the area bounded by the curves x equals to ay square and y equals to ax square is 1, then we need to find the value of a. So we can see that we are having the two parabolas here. Plotting these two parabolas, x equals to ay square and y square equals to ax square, we can see that these two intersect first at origin and then at this point. So we can find the point of intersection as solving these two equations simultaneously, putting the value of y in here. So x will be equals to a into ax square whole square. So x will be equals to a cube. So on solving, this will be x cube. So x cube will be equals to 1 upon a cube. So x will be equals to 1 by a. On putting x equals to 1 by a, y will also come out to be 1 by a. So we can see that this has coordinates 1 by a comma 1 by a. Now the area enclosed between the two curves is given to be 1, and from here we can see that this curve is having the equation x equals to ay square, or we can say y equals to root of x by a, and this curve is having equation y equals to ax square. So we need to find the area enclosed from 0 to 1 upon a under the root x by a, this curve minus this curve dx. Applying the basic integration, see this is x to the power 1 by 2 upon a to the power 1 by 2. So x to the power 1 by 2 integration will be x to the power 3 by 2 upon root a and 2 by 3 minus a x cube by 3, and putting the limit 0 to 1 by a. If we will put the limit in here, so we will be having plus 2 by 3 a to the power minus 3 by 2 upon a to the power 1 by 2 minus a into a to the power minus 3 upon 3, and this area is coming out to be 1. So if you will solve it, so we go up, then this will be 2 by 3 minus 1 by 3 into a to the power minus 2 equals to 1. So that will be 2 by 3 minus 1 by 3, that is 1 by 3. So 1 upon 3 a square equals to 1. So a square will be equals to 1 by 3. So a equals to 1 by root 3. So our correct option is option A. Now moving to the next question, we have to find the area between the curves y equals to x minus 1 square and y equals to x plus 1 square and y equals to 1 by 4. So we can see that this is an equation of parabola, this is also an equation of parabola. So y equals to x minus 1 whole square will represent a parabola whose vertex is at 1 comma 0, and put x equals to 0, so y will be equals to 1. and y equals to x plus 1 whole square also represents a parabola whose vertex is at minus 1 comma 0. These two will intersect here at x0 and y equals to 1, that is 0 comma 1, and we are having a line y equals to 1 by 4, so that line will be this one. Now we have to find the area enclosed between these curves, that is this area. So for this area we can see we are having this point and this point, and the area along the first quadrant and area along the second quadrant, both these areas will have the same magnitude. So we have to just find this point. So it's very easy because we are already having y equals to 1 by 4. So 1 by 4 is equals to this curve is y equals to x minus 1 whole square, and this curve is y equals to x plus 1 whole square. So this is 1 by 4 equals to x minus 1 square, that is x minus 1 equals to 1 by 2. Or you can directly find the area with y-axis, then you won't need to find this point also. So this you can integrate from 1 by 4 to 1. So integrating from 1 by 4 to 1 x dy, and the value of x will be y is equals to x minus 1 whole square. So root y plus 1 is equals to x. So this value will be integration 1 by 4 to 1 root y plus 1 dy. On integrating this value, we will be getting y to the power 3 by 2 upon 3 by 2 plus 5, and limit from 1 by 4 to 1. Substitute this value and find the value. You will be getting it equals to 1 by 6. Okay, simple substitution, you will get 1 by 6. So 1 by 6 is the area in this first quadrant. Similar area is formed in this second quadrant, so this will be also 1 by 6. So the total area will be 2 times of this area, we can say. So that value will be equals to 1 by 3. So our correct option is option number A. Moving to the next question. Let the straight line y equals to b divide the area enclosed by y equals to 1 minus x whole square, y equals to 0 and x equals to 0 into two parts. First part r1 is from 0 to b and second part r2 is from b to 1. It is given that the area r1 minus r2 is equals to 1 by 4. Then we need to find the value of b. So first of all, r1 is 0 to b y dx. So it will be 0 to b 1 minus x square dx, and r2 is from b to 1 y dx. So that will be b to 1 1 minus x whole square dx. So on integrating, you would be getting 1 minus x whole cube by 3, and since the coefficient of x is minus 1, so you'll get a minus sign here, and the limit will be from 0 to b. Similarly, in this case, it will be 1 minus x whole cube by 3, and due to the coefficient of x minus 1, we'll get a minus sign in here, and limit be to 1. We are given r1 minus r2 equals to 1 by 4. If you will solve this, you will get the required answer. So on putting these limits, we will be getting first b minus 1 whole cube by 3 minus of minus. So if we'll put 0 in here, so that will be minus 1 by 3. So that will be plus 1 by 3. And this is, so on solving x equals to 1, it will be 0. And on putting b, so minus of minus, that will be again plus. So that will be b minus 1 whole cube by 3 equals to 1 by 4. So this is our 2 times. and this 1 by 3 will go that side, and on solving you will get the value of b equals to 1 by 2, because b minus 1 whole cube will be minus 1 by 8, that implies b minus 1 is minus 1 by 2. This 1 will be shifted that side and b will be equals to 1 by 2. So our correct option is b, that is 1 by 2. Now moving to the next question. The area enclosed by the curve y equals to y sin x plus cos x and y equals to mod of cos x minus sin. See, for this value, mod of cos x minus sin x, we already know the graph of sin x and cos x. For sin x, the graph is this, and for cos x, the graph goes like this. This is the point pi by 2. At this point pi by 4, so from 0 to pi by 4, our cos x has more value than sin x, and we are looking for the interval of 0 to pi by 2, and from pi by 4 to pi by 2 the sin x value is more than cos x, so we can rewrite it as this will be equals to cos x minus sin x for x belonging to 0 to pi by 4, and for x belonging to pi by 4 to pi by 2, this value will be sin x minus cos x, because then the value of sin x will be more than cos x. Now we have to find the area enclosed between these two curves. So if we are saying this is y1, this is our y2, so we need to find area from 0 to pi by 2 y1 minus y2 dx. So that will be 0 to pi by 2 pi by 4. We are having this is a break function and it is breaking at x equals to pi by 4. So we have to put the limit from 0 to pi by 4 one time, and then this y1 is sin x plus cos x minus, so y2 is cos x minus sin x dx, and plus from pi by 4 to pi by 2, our y1 is fixed, that is sin x plus cos x, and our y2 will be sin x minus cos x dx. See, this minus sign will go inside, minus cos x and minus of minus plus sin x, so cos x and cos x will cancel out, so we will be getting 2 times of sin x, and here minus sin x plus cos x, so sin x will be cancelled out and we would be getting 2 times of cos x. So on putting the limits and then solving, you will get answer to with this one. Or if you are looking at this one, then it was 0 to, so we were having from 0 to pi by 4, it was equals to 2 cos x dx, and from pi by 4 to pi by 2 it was 2 sin x dx. 2 will come out to be common, and for cos x the integration will be sin x, and limit is from 0 to pi by 4, plus sin x the integration will be minus of cos x, and limit is from pi by 2 to pi by 4. And put these values and solve, and you will get the required answer. So our option, that was B. Now, moving to the next question. The area bounded by the curves y equals to log x, y equals to log of mod x, and y equals to mod of log x, and y equals to mod of log of mod xs. So what we have to do is let's plot them. So for y equals to log x, y equals to log of mod x. So this area will be obviously there for x greater than c. Y equals to log x will be this curve. For y equals to log of mod x, we will write it as log x for x greater than equals to 0. And if x will come out to be negative, then also the function will be same, but we can consider the negative values of x also here. So for x minus 1, this will be 0, and this curve will be like this. Then thirdly, y equals to mod of log x. So mod of log x is again only this curve, because we will be getting only the positive values of y. And y equals to mod of log of mod x. So this is this curve. Okay, when we will be having this values, so for y equals to mod of log x, the negative value will be not there, so this part will come out to be like this and this. So we can see that the required area we are finding here is this area. So we have to just do the basic integration of 0 to 1 log x dx. See, this area and this area will be magnitude wise same, and we have to find this area is 2 times of this area. So this is 2 times of 0 to 1 log x integration of log x dx. So this will be 2, 1 into log x, so integrating it by parts, so it will be x log x minus x and limit 0 to 1. Putting these values and solving it and putting the values, so we will be getting 2, and this will be 4 units, because this will be 2, 1 plus this for x, limit will be from 1 minus 0, so it will be 1, so our answer will be 4 units. So our required answer is answer A. Moving to the next question. Our next question is the area of the region bounded by the curve y equals to mod x minus 1 and y equals to 3 minus mod x. So what we can do here is we can plot these curves. So y equals to mod x minus 1 is this line, and y equals to mod x minus 1, we can write it as x minus 1 for x greater than equals to minus x plus 1 for x less than 1, and y equals to 3 minus mod x, you can write it as 3 minus x for x greater than equals to 0 and 3 plus x for x less than 0. So for this x equals to 0, y will be equals to 3, and slope is negative. This point was 1 comma 0. It will be like this, 3 comma 0, 0 comma 3, and here it will be this, minus 3 comma 0. So we have to find this area bounded between these two. What you can do here is, you can see that the slopes, this angle is 90 and this is 90 because this is having slope minus 1 and this is having slope plus 1. Similarly, this is having slope plus 1 and this is having slope minus 1. Okay, so these angles are 90 degree. Moreover, these angles are 90 degree. So we can see that it is a rectangle. And if it is a rectangle, then we can find the area by length into breadth. So we can find this points of intersection. We are having this point. So this line was y equals to 3 minus x, and this line was y equals to x minus 1. So x minus 1 equals to 3 minus x. So 2x will be equals to 4. So x will be 2. Put x equals to 2 in here. Y will be equals to 1. Similarly, for this point, the equation in here was y equals to minus x plus 1, and this equation was y equals to x plus 3. Equating this, x plus 3 equals to minus x plus 1, so 2x will be equals to minus 2, x will be equals to minus 1. So this point is x equals to minus 1 and y equals to 2. So by a simple distance formula, you can find the length under the root 2 minus 1 whole square, 1 plus 1, that will be root 2. This length will be also equals to root 2. Now this length, distance formula, 1 minus under the root 2 minus 0, that is 2 square, plus 2 square, so that is under the root 8 or 2 root 2. So length into breadth, our answer will be 4 square units. So this is one of the way in which you can find the area without using integration. Otherwise, you have to do the integration and by putting the limits. So from minus 1 to 0, you have to write this line, then minus this line, then from this to this, and then subtract these lines. Okay. So you are having two methods of doing this. Moving to the next question. The area of the region bounded by the curve y equals to mod x minus 2, x equals to 1, x equals to 3, and x-axis. So let's plot the area. Y equals to mod x minus 2. Again, that will be equals to x minus 2 for x greater than equals to 2 and minus x plus 2 for x less than 2. So we will be having these two straight lines. And we are having x equals to 1. And we are having x equals to 3. So we are required to find this area. So first of all, the equation of this line is y equals to minus x plus 2. If you will put x equals to 1 in here, so y will be equals to 1. And this equation is y equals to x minus 2. If you will put x equals to 2 in here, then equals to y will be equals to 1. So we are having the total area will be equals to the area of this triangle plus area of this triangle. So this length was 1, this length will be 1, and this length will be 1. So that will be half length into breadth plus this area will be half length into breadth. So the total answer will be 1. So our option C is correct. If you have to do this question from integration perspective, then you have to use the integration from 1 to 2 and you are having this line, you have to integrate this value minus x plus 2 dx, and from 2 to 3 you are having this line, so from 2 to 3 the integration will be x minus 2 dx. Solve this by using the basic properties of integration, that is x to the power n, you will be getting the integration x to the power n plus 1 upon n plus 1, and then the required answer will be 1. Moving to the next question. So the question is, area of the greatest rectangle that can be inscribed in the ellipse. Okay, this question does not belongs to basically area under curve, and we can see that if we are having a rectangle x square by a square plus y square by b square equals to 1, and we have inscribed a rectangle inside it, and we are required to find the area of the greatest rectangle that can be inscribed, that is the area of this rectangle should be maximum. So if you are taking it like for ellipse x square by a square plus y square by b square equals to 1, x equals to a cos theta and y equals to b sin theta are our parametric points. So this point will be, if this point is a cos theta comma b sin theta, then this coordinate will be a cos theta minus b sin theta, and this coordinate will be minus a cos theta comma b sin theta, and this coordinate will be minus a cos theta comma minus b sin theta. So we can find the length will be equals to 2 times of a cos theta, and the width will be equals to 2 times of b sin theta. So our required area of this rectangle is length into width. So you can see that the area will be equals to 2ab sine 2 theta. See, from 2 cos theta sine theta, it is equals to sine 2 theta. To find the maximum or minimum, we know the basic concept of maxima and minima. So for the maximum or minimum area, dA by d theta should be equals to 0. So if we'll be finding dA by d theta, then it will be 2ab. The differentiation of sine 2 theta will be cos 2 theta into 2. And for the maximum value of area, dA by d theta should be 0. So this implies that cos 2 theta equals to 0. This implies that 2 theta equals to pi by 2, that is theta equals to pi by 4. Okay, so theta equals to pi by 4 is our point for the maximum area. So our area was equals to 2ab sine 2 theta, and theta put pi by 4. Pi by 4 into 2 will be pi by 2, and sine pi by 2 is 1. So our area will be 2ab. So the correct option is B. Now moving to the next question. We are given, let fx be a non-negative continuous function such that the area bounded by the curve y equals to fx, x-axis, and the ordinates x equals to pi by 4 and x equals to beta is this. Then we have to find the value of f of pi by 2. So we can see it is given that when you are finding the area from pi by 4 to beta of fx dx, you are getting this area as beta sine beta plus pi by 4 cos beta plus root 2 beta. Now what we can do here is we can directly differentiate both the sides. So f of beta will be equals to, here product rule will apply to 1 into sine beta plus beta into cos beta plus pi by 4, sine beta will be equals, differentiation will be equals to minus sine, cos beta, differentiation will be minus sine beta plus root 2. So this will be the value of f of beta. We have to find f of pi by 2. So f of pi by 2 will be sine pi by 2 is 1. This will be 0 minus pi by 4 plus root 2. So our correct option will be option C. Now moving to the next question. The area enclosed between the curves y equals to log of x plus e to the base e and the coordinate axes. So first of all, let's sketch the curves. So the x is y. When you will be putting y equals to log x plus e to the base e. So when x will be equals to 1 minus e, so y will be equals to 0, because log 1 is 0, and uh, x is equals to 0, that means log e to the base e, so that will be 1. So our curve will go from this to this. Now we can see we have to find this area, the area enclosed between the curve and the coordinate axis. So this point is x equals to 1 minus e, and this point is x equals to 0. So integrating from 1 minus e to 0 log x plus e dx. Use product rule. So this will be equals to, so that will be equals to x log x plus e minus x upon x plus e integration, I guess.
Sorry, I don't know that.
So using this integration in here, you can either do the substitution or you can directly integrate it. If you are doing the substitution, that is x plus e equals to z, then dx will be equals to dz, and the limits will be when x is equals to 1 minus e, z will be equals to 1 minus e plus e, that is z equals to 1, and when x is equals to 0, then z will be equals to e, and the product rule will be z log z minus z into 1 by z dz. So the integration will be z log z minus z, and our limit is from 1 to e. So putting e, log e will be 1 minus e, that will be 0, minus, when you will put 1, so log 1 will be 0, and this is minus 1. On solving this, you will get as the area will be 1. So our required answer is B. Moving to the next question. We are given there are two parabolas y square equals to 4x and x square equals to 4y, and they divide the square region bounded by the lines x equals to 4 and y equals to 4 and the coordinate axis. If S1, S2 and S3 are respectively the areas of these parts numbered bottom to top, then S1 is to S2 is to S3 is. So if you can see here, then the curves are, this curve is r, x square equals to 4y, and this is y square equals to 4x. Now this area is S1, this is S2 and this is S3. We can see that S1 and S3 should be equal by symmetry. Now we have to find S2. So if you will find S1, S2, S3, so for this area S of 3 is integration y dx, and the value is x equals to 0 to x equals to 4, and the value of y is x square by 4, so that will be x cube by 4 into 3 and limit 0 to 4, so that will be 16 by 3. Now this area is 16 by 3, this area will be also equals to 16 by 3, and we can see that this square will have length into breadth, that is 16. So the combined area is 16 and these two areas are 16 by 3, 16 by 3. So this area must be 16 by 3. Then only the combined area will be 16. So we can see that all the three areas are equal. So S1 is to S2 is to S3 will be equals to 1 is to 1 is to 1. Now moving to the next question. The area enclosed between the curves y square equals to x and y equals to mod x's. So y square equals to x and y equals to mod x will be this line. So we have to just find this area enclosed from x equals to 0 to, if you will find the point of intersection for y square equals to x and y equals to x, so it will be x equals to 1 and y equals to 1. So from 1, so we have to do integration from 0 to 1 for this curve y, that will be root x dx. So x to the power of 3 by 2 upon 3 by 2 and limit from 0 to 1. So this will be 2 by 3. So 2 by 3 is the total area, and we have to find this area. So we have to subtract the area of this triangle. So the area of the triangle will be half length into breadth, so it will be 1 by 2. So the curve shaded area, this area will be equals to 2 by 3 minus 1 by 2, so that will be 4 minus 3 by 6. So the answer will be 1 by 6. So our required answer is option A. So this was area under curve. Thank you.